So yeah, 7.1 was just the introduction to confidence intervals. And so we talked about what estimation was, right? And so remember we did this first example where we made like an interval, not necessarily a confidence interval, but we constructed these intervals by just adding and subtracting that number. And then we moved on and we started talking about what confidence intervals actually were and the reliability of them. And so remember we talked about this critical value, and the critical value is just the area of the confidence level that you're given, right? And so remember we talked about how if this were a two-tailed test, then the pieces right here, like the area of this alpha 0.02 or alpha 0.05 over 2, that would be alpha over 2, right? If this were a two-tailed test. And so at the very end of talking about confidence intervals, we're going to be connecting confidence intervals and hypothesis tests. So it's going to be really important that you understand both of them, right? Because we're going to be doing some problems where you start with a hypothesis test, you find the confidence interval, and then you make a conclusion about the hypothesis test based on the confidence interval that you found. It's actually pretty cool. If you have taken Stats 1202 at Cal Poly before, I want to say it's not something that's normally covered. And so I'm going to cover that instead of two population stuff, which we might also get to at the very end if we have time. But so yeah, are there any questions about like just kind of the idea behind confidence intervals? We're going to start making some today with actual numbers, right? And so here's an example I did at the very end, right? I wanted to see how many people went to Carl's Jr. on average for an entire year, right? Not just those 30 days, or not for an entire year, but just over a random amount of time. And so I found, instead of finding one number for the average number of people that go there, I found a range of numbers for the number of people that go there, right? And so that's what we're going to be doing this entire chapter. And so we're going to be working on 7.2, which is confidence intervals for means. And so remember, you have means and you have proportions. And so in this section, we're only talking about the mean mu. And then in 7.3, we're going to be talking about the proportion p, right? So it's very similar to hypothesis testing in the way it kind of breaks down like that. But okay, so here, oh, oh, hang on real quick. There we go. So yeah, the very first definition that we need is the point estimate for mu. And so the point estimate for mu is going to be, so mu is the population parameter. What is the sample statistic that goes along with mu? But yeah, it's X bar, right? And so mu is the population parameter, and X bar is the sample statistic that goes with it. And so remember, it's really important to know the difference between the statistics and the parameters, because when you're doing hypothesis testing, you're testing the parameters. And when you're doing confidence intervals, you're estimating the parameters. And in both of those cases, you're using your sample statistics to do those things, right? And so just make sure you know that, because there are some questions on the exam that are going to talk about that. Oh, you know what? I just realized that this statement, so I was making these notes kind of quickly right before we had to go online. And so here, this sentence is not in the right spot. Yeah. So just take all of this out. This is for proportions. But okay, so if we move on to those requirements, then what do you think the first requirement is? What kind of sample do you think we need? Yeah, it has to be random. And so And it'll always have size n, right? That's the variable we're always going to use for sample size. The second requirement is that the x-bar distribution is normal. And so remember, that's when, so if you're told that it's normal, you don't need to check for n being greater than 30, right? So if you're given that it comes from a normal distribution, you don't need to do part B here, which is checking the sample size is bigger than 30. And so here, you only need this if A is not satisfied. And so there will be some questions that give you a sample size smaller than 30, but will say normal. So you need to be very careful and you need to read them very carefully, right? But so let's look at this first example down here. So a random sample of size n equals 35 has a sample mean of 34.85. So that means this 34.85 is my x bar, and a sample standard deviation of s equals 17.9. And then it just asks us if the requirements are satisfied. And so the first one, since it starts out by saying the sample is random, I know the first requirement is satisfied. So random, yes. And then the second one, I'm not told, so is x normal? And the answer here is we don't know, right? We do not know, so don't know. So now I'm gonna check to see if n is greater than 30, and since it is, then I know the requirements are satisfied. So are there any questions about this one? Or about the requirements here? Hang on, I'll write that down in a second. So here, n greater than 30, yes. So x bar is normal. And so remember, that's the difference between the like x distribution and the sampling distribution for x bar. So if you're kind of forgetting the difference between x and x bar, go back to sections 6.4 and 6.5. Remember, there were all those questions where it was like, what's the mean of these 5 fish versus the mean of this 1 fish, and things like that, right? And so that's when you talk about the difference between x and x bar and their distributions. But so, okay, yeah, are there any questions about checking the requirements here? All right, so let's move on to the next page. So we're done with page 1. Page 2 is finding those critical values. And so there are 2 different ways to do this, or 2 different, not ways, but 2 different cases, I guess, right? And so the first case is the same thing as when you're dealing with hypothesis tests. Either sigma is known or sigma is unknown, right? And so depending on which variables you're given, it's going to change how you solve the problem. And so here, for this first definition, the critical value when you're given sigma, it's a z-score such that the area under the standard normal curve, right? And so remember, the standard normal curve is mean 0, standard deviation 1. And so it's the z-score such that z and negative z is equal to the confidence level. We've already talked about the critical value, just in a different kind of setting, right? And so we're still going to use the same notation, which is z sub c. And so here, if you look at this picture, right, the area is just the stuff in the middle, and the critical values are now, well, I guess it's just one critical value, but it's the positive and negative version of that critical value are the boundaries of your critical, or not your critical area, right? This is not the critical area. The critical area would be this in a two-tailed test. This is, I'm not entirely sure what region you would call that, but it's what bounds the confidence level, right? But do you guys have any questions about this? Does this make sense so far? Okay. So you guys remember how when we were doing hypothesis testing, we used the critical region method when we knew sigma, but then when it came to not knowing sigma, I told you that we couldn't use the critical region method. It was technically a lie. I just didn't want to cover it. There's a way that you can do it, but it's not the same way that you do it when you know sigma. And so here, we're going to cover it when, so what's it called? So we are going to talk about the critical value when you don't know sigma, which is, I think I had told you before that there isn't a critical value. The only thing is, it's no longer a z-score. So the critical value denoted now with a t. And so when you don't know sigma, remember, so we used like t-test when we were doing the hypothesis testing. And so our critical value is going to have t sub c. And what this is it's just a number, and it's the area under the student's t distribution. So remember that one, I think we had talked about it when we still had class in person, right? Where this guy was working at a brewery and he was trying to get ahead in the competition, and so he like developed this new distribution and called it the student's t distribution. But yeah, again, it's the same thing, right? So between negative t sub c and positive t sub c is the area, right? Which is also the confidence level, which is going to be given by the letter C. And so yeah, this picture, it's the same thing down here, but we have degrees of freedom now, right? So I want to say the first time we talked about degrees of freedom in the student's T distribution is either an 8.3 or 8.4. So if you're kind of like not really remembering what I'm talking about here, go look through those notes and then let me know if you have any questions. But I mean, the curves look almost exactly the same. It's just this one is not the standard normal curve, it's the student's T curve. And so that's why we're not allowed to do anything with the normal distribution, right? We can't use inverse norm, we can't do anything like that. So not the standard normal curve. But so yeah, any questions about this? Okay, so I'm gonna go to the next page. Oops. All right, so here, find the critical values for each of the following scenarios with C equal to 0.95. So the first one says the general social survey randomly asked 1,972 adults how many years of education they have. The sample mean was 13.37 years with a standard deviation of 3.13 years. Okay, so it wants us to find the critical values. And so, oh, you know what? I don't think we can do this first one just yet. We're gonna have to come back to this one. So we're gonna do part B and then we'll come back to part A because I just realized I haven't actually given you what you need to find part A yet. Because we have not talked about that table, which I'll talk about on Wednesday. Today, we're just gonna talk about what happens when you know sigma. So this right here, when it says with a standard deviation of 3.13 years, so with a standard deviation, which standard deviation is this? Is this the sample standard deviation or the population standard deviation? Be the sample one, right? Because it's saying the sample with a standard deviation of 3.13 years, right? And so just kind of keep that in mind. There are going to be some questions like this on your exam that are worded like that. So this means S is equal to 3.13. And so we're just going to do part B first because we know how to take care of this one. But so here it says in a random sample of 77 children, the mean age at which they first begin to combine words was 16.51 months, and assume the population has a standard deviation of 9.59 months, right? So this is, what's it called? Sigma. And so here, what I'm gonna do, and so C is 0.95 for both of these examples. And so if I draw out a picture, C is 0.95, and C is always the values in the middle of the critical values that we wanna find. So if I'm told that this is 0.95, and I want to find, and I want to find negative Z sub C and positive Z sub C, what can I do? What function in my calculator should I use to find negative Z sub C? So think about it this way. How did you find the critical value when you were doing hypothesis tests? What function in your calculator did you use for those?
Inverse norm.
Yeah, so Z-test was to make a conclusion about the hypothesis test, but to find that critical value. Z-test also gives you the test statistic, right? But the critical value is found. So if I want to find negative Z sub C, so negative Z sub C, it's going to be inverse norm. And then here, if I'm trying to find negative Z sub C, that means I'm trying to find the area, or I'm trying to find the value which has area to the left of this value. And so what is the area to the left of negative Z sub C?
(0.05/2).
Yes, exactly. 0.05/2, because this is also going to be 0.05/2, right? And so the entire thing, like on the sides, total, I would have 0.05 left. But because I have two separate pieces kind of both being left out, I have to now divide that by 2 and split it in half, right? Because everything's perfectly symmetric in this curve. Oh, ow. And so here, when you plug this into your calculator, you're going to do inverse norm 0.0501 because it's the standard normal curve, so you still use 0 and 1. But then here, you should always get a negative number, and I have my calculator. So second distribution, inverse norm 0.0501. And so when you're doing the negative Z sub C, you should always get a negative number here. So negative 1.645. So everybody go in your calculator and make sure that you can get the same answer. Make sure you know how to put this into your calculator. I mean, we all should by now because it's the same thing as when we were doing hypothesis tests.
Wait, I have a question.
Yeah.
Well, why is it 0.05 on the end again?
Oh, hang on. This should be 0.05/2. It's, okay, so the sum of everything under the curve should be 1, right? And so if this is 0.95, then I know the remaining part. And so by this, I mean like in here, right? This whole piece. And so that means these pieces, these blue pieces, have to add up to the remaining area, which is 0.05. And so that's why it's going to be 0.05/2, because I have 2 pieces left out. but the only total area I have left out is 0.05. Does that make sense?
Yeah, okay.
Okay.
Yeah, that makes sense.
Okay. And so yeah, when you do this, you should have 0.05 over 2 right here, not 0.05. I messed up right there. And so yeah, if you fix that, so 0.05 divided by 2, you can just put this into your calculator just like that, by the way, and it'll still calculate it for you. And so here, instead of negative 1.645, I'm now getting negative 1.96. Okay, so yeah, any questions about how to find negative z sub c? Do you see any other mistakes that I made? How can I find z sub c without using inverse norm now? So think about why I'm allowed to say this is 0.05 over 2 and this is 0.05 over 2, right? I know that these two pieces are equal, are exactly equal. So what does that mean about these two values right here? What can I do to negative z sub c so that it equals positive z sub c?
Just take the negative off the 1.96.
Exactly, or I can take the negative of it, which will still make it positive, right? So you can just make your negative z sub c positive, basically. Right, so if I kind of write it out using multiplication, this is what it would look like, right? Take the negative of negative z sub c, and then you have the negative of negative 1.96, which is going to be positive 1.96, right? So those would be your two answers right there. Z sub c equals that, and negative z sub c equals negative 1.96. Are there any questions about how to find critical values like this? And so it's essentially just finding the critical value when you're doing a two-tailed test, right? But instead of being given the area of the critical region, you're kind of being told the exact opposite area. All right, so let's go over the kind of procedure for constructing a confidence interval. And then we'll do an example when we know sigma, and then we'll come back to all the stuff when we don't know sigma, because there's some stuff I forgot to give you before going over this. But so basically, the first thing that you do is you check the requirements, right? It's always, always, always the first thing that you do. But then you need to, if you're not told these two things, then you need to compute the sample mean and identify sigma, right? Most of the time you'll be given X bar. I want to say every time I'm making sure to give you X bar. And then the next thing that you do after figuring out what those two things are is you find that critical value that we just found up here. And then after that, you use that to find what's called your margin of error. And so that's one of the things that we had talked about before spring break. And remember, that's given by the letter E, and that's the number that you add or subtract to your point estimate to make your interval, right? And so here, to find E, you're going to take your critical value, and you're going to multiply it by sigma over the square root of your sample size, which is n. And so this is a calculation that you're going to have to do by hand. There's nothing in your calculator that can give this to you. And so you have to make sure that you know that formula. After you figure out your margin of error, you're going to take your point estimate, which remember we talked about in the beginning of this section, that's X bar for this section. And then you take that and your margin of error to construct the confidence interval. And so you're going to have X bar minus E x bar plus e, and then what should go right here? Actually, hang on. So yeah, it would be mu. Oh, whoa. Because that's what you're trying to estimate. So you're trying to say mu is between these two values, right? And then the last thing that you do is you're going to give an interpretation. So this is very similar to hypothesis testing. Check the requirements, kind of figure out what your variables are, do the right sort of test to find the critical value. But then it starts to change around 4 and 5, right? But then the last one, it ends the same too, give an interpretation. So now that we have all the pieces to actually solve a confidence interval now. And so if we go and we look at these examples, so are you guys okay with me scrolling, or did I go a little too fast? I feel like I went kind of fast.
You can scroll.
Okay. So I'm gonna go to, so let's figure out which one of these we can do, right? Because there's an example on page 4, and there's an example on page 5. And here, this box is for finding it when sigma is unknown. And so yeah, we'll talk about that on Wednesday. But so here, the general social survey, oh, it's the same one from above. And so this was the one where we already figured out that this is S. And so we can't do this one just yet because we don't have sigma, right? And so we're gonna have to do this next one. So I'm gonna go to page 5. And so here, these are the same ones from above. So I already know that's N, I already know that's X bar, and I already know that this is sigma. We've already checked the requirements. So I'll just put requirements checked on page 1. But we should still sort of acknowledge that we need to check them. The second thing was to figure out your variables, right? And so I've already kind of written it down up here, but let's write it down here. So N is equal to 77, X bar is equal to 16.51, and sigma is equal to 9.59. And then there's one other variable that I'm given here that I was not given when we did this example earlier. What is this 98% going to represent? What letter should I give that?
See?
Yeah, so this is going to be C, but when I use it, I'm going to use 0.98, right? Like when I draw out my picture and when I put it into my calculator, although you don't ever put C into your calculator. But so here, if I draw this out, oops. And what this means is I have negative Z sub C here, Z sub C here, and then this is 0.98. So what is this one going to be? So if I have 0.02 left, then what is going to be on either side? All right, so you're going to have 0.02 over 2 or 0.01 on either side. And so yeah, that's why you have to pay very close attention to what's here because it's going to change what goes on the outsides here. But so then I can use this picture on my third step. And so I'll find negative Z sub C first. And so that's still going to be inverse norm. But what value am I going to put there now?
Zero 0.01.
Yeah, the 0.01. And so I just realized if when you're doing this, you can do this part as percentages. And then if it's kind of easier to think about in percentages, then yeah, that's totally fine, right? Because you would have 1% on either side there, and then you would just have to convert those to decimals, because here you can't put a percentage there, it has to be a decimal. But so yeah, it's just kind of however you want to think about it. Just make sure when you put it into your calculator that you know how to do it correctly, right? But so here for negative z sub c, let's see, inverse norm, 0.0101, and I'm getting negative 2.33. If that's wrong, somebody tell me, or if you got something different.
I got the same thing.
Okay, cool. And then yeah, again, to find positive z sub c, I'm just going to take the negative of the negative one, and so I'm going to get 2.33, the positive of that. And then real quick, we're going to have to finish this example on Wednesday because we only have 2 minutes left, but we can find the margin of error real quick. So let's do that. So E is the margin of error, and that's going to be z sub c times sigma over the square root of n. And so I have all of those pieces now, right? In steps 2 and 3, I can kind of piece it all together. And so z sub c is 2.33, because it's the positive version, right? Times sigma, which was 9.59, over the square root of 77. And so you should make sure that you know how to put this one into your calculator too, just in case. 2.33 times 9.59 divided by the square root, oops, what was that? Square root over 77. And so I'm getting 2.55. Are you guys getting something similar or the same thing?
The same thing.
Okay. And then yeah, what we're gonna pick up with on Wednesday is step 5. And so we're gonna do x bar minus e and x bar plus e. But we'll do that on Friday. Not on Friday, on Wednesday. Wednesday. But are there any other questions about this before I stop the recording? Do you have the TI 83? So the person who just asked about calculators? Because it's second, and then above the x squared button, there's a square root button. And so to get the yellow one, you have to press second before you do it. And so it's on the left side in the same column as the second button. Maybe not.